Hello everyone. Today I thought we would look into something kind of retro and fun. And the way we're going to make it retro and fun is we're going to use some of those old retro ICs. If you've bought one of the kits available on the website, you'll probably recognize some of them. I include them because they're so flexible. You can do so very many things with them, sometimes things that you wouldn't first really expect. So what we're going to start with is an amplifier called an LM386. Some of you may recognize the LM386. It's real popular with musicians for making little flea power guitar amplifiers. Some people have made headphone amplifiers with them. I don't know if I would want to use it for a headphone amplifier, but you can use it for that as well. It's a little amplifier that runs off a single 9-volt battery and puts out about 1 watt of power. A watt doesn't sound like much, and well, it really isn't. There's a lot more modern chips that'll put out 5 or 6 watts from a 12-volt battery. But they're a little more sophisticated. There's a little bit more to them. The cool thing about the 386 is they're inexpensive enough that you can use a lot of them. It's not going to be a big deal if you fry one. And it's just a cool old chip. It's something that's been around for a while. So I like building things with cool old chips. I think cool old chips are a lot of fun. The cool thing about this particular project is that it combines a couple of cool old chips. We have our LM386 there, and what I think we need to make it even cooler and more retro is an LM555. There. Some of you may recognize an LM555 or an E555 or an SE555. Basically, it's a 555 timer chip. 555 timer chips have been around, I believe, since the 70s. They're so popular in some circles that there have been design contests to see how many cool things experimenters and hackers can come up with to use with a 555. I don't know if you can hear the train. If you can, excuse the train. I live close to the railroad tracks. I don't mind it. I like the train, except sometimes it comes through at the wrong time. So here's our 555, and we're using the 555 in free running mode as an oscillator. Now we use these 2 resistors here. These 2 resistors set the frequency. I'm going to make that one a 420 because 420s are real common, and I'm going to make that one a 10K because 10K pots are also real common. And now by adjusting this potentiometer, we can change the oscillation frequency. If we make this cap here 150 puff, then we're going to find we have an oscillation frequency is somewhere around 1 megahertz to 2 megahertz, something like that. Some of you may recognize the 1 megahertz to 2 megahertz range as the AM broadcast band, and that's a good clue as to where we're going with the circuit. There's pin 3, there's the business end of the 555, and we're going to couple that through a capacitor, and we're going to run all that into a transistor. The transistor will amplify the signal from the 555 and shape it a little bit, give it some filtering so that it's a little more rounded, not quite so square. Now, let's put that in for later. I'll talk about that in a minute. And we'll bring over our power supply there. And there's our resistor for our transistor amplifier, and we're going to add a resistor here to stabilize it, to set the gain. If we make this a 20K resistor, and we make this one a 200K, and those are not critical. That can be a 10K and a 100K, that could be 150K, that could be 220K. It really comes down to whatever you've got on hand. Just like this is a 20 and this is a 0.01, it could just as well be a 0.001. It could be a 0.1. It's basically, it's there to couple this signal into this circuit. Ideally, you want it to couple less of the DC, so it's better to fudge toward a lower value than a higher value. But anything will get you by right there. And now what we've done is we've created an amplifier here for a 555 signal. And we'll take that signal and we'll couple it through yet another capacitor. And we'll put a resistor down here. And you see this resistor sets the input impedance and helps bias the next stage, which is yet another amplifier, another transistor. Now, if you have the kits available on the website or on eBay, chances are you've got a bunch of 2N3904s and a bunch of 2N4401s. If you're building this, you might want to use a 3904 for that and a 4401 for this, because the 4401 will pump out just a tiny bit more power. That'll work out well for you as far as putting out a little bit more output power for your transmitter. Now here's the cool part. We have this beginnings of an amplifier right here, but we don't have any way to bias this transistor yet. This transistor has to be biased in order for it to operate as an amplifier. And this is where our 386 comes in, because the 386 has this really cool feature where it biases itself to 1/2 of the power supply voltage. In this case, if we're running it from a 9-volt battery, this is going to be about 4.5 volts. And that 4.5 volts is ideal for coupling through an inductor into our transistor circuit here, you see? And again, if you have the kits available on the website, chances are you have a bunch of 20 microhenry inductors. They're going to be in a little plastic blister pack about that long, probably 4, 5, or 6 of them, something like that. I believe they're 20 microhenry, and they should work just fine for this. That is going to keep the RF that is here out of our 386 amplifier. Our 386 amplifier is at the same time biasing this output stage. And this output stage we just couple through another inductor. It can be just like that one. And we put a capacitor here, and we put a capacitor here. And these two capacitors and this inductor form what's called a pi filter. And the pi filter helps shape the output of our amplifier, of our transmitter circuit. So we can use, let's see, a 0.001 there. There should be plenty of those in the kit. And this right here is tricky because there are no variable capacitors in the kit. And ideally, that should be a variable capacitor. But there's a really cool trick that you can use to make a variable capacitor. And the way that you do that is you just take a couple of pieces of wire, just standard connection wire. Here I'm going to use the wire from a battery clip. And you just take your two pieces of wire and you twist them together like this. And when you twist them together like that, what you're doing is you're forming two plates of a capacitor. And you can just twist about 20 turns of wire together like this. You don't connect the ends together, you cut it off right there. You solder these here and here, and you can adjust this capacitance by loosening and tightening these twists of wire. And in that way you're able to make an adjustable output capacitor. And that's ideally what you want here, because this capacitor here will help tune your antenna for maximum power output. So I hope this illustrates well for you the potential and the versatility of a basic kit full of parts. You know, just apparently random parts, seemingly random at first. I can assure you that if you have one of the kits available from my website, they're not just a random collection of parts. Those kits were put together with the specific intent of making it possible for you to build at least 3 really cool projects. That's why there's 2 battery clips, there's a bunch of headers so that you can connect it to your Arduino board. There's op amps, there's LM386s, there's 555s, there's 78 LO5 low power regulators. And what we're going to do with that regulator, you say, is we're going to put it in the circuit here, We're going to put a cat there, and again it's non-critical. And we're going to put a cat there, and again it's non-critical. And what we've done there is we've built a regulated power supply for our oscillator. And that will give the oscillator more stability, and it will make the sound better. It will make less spurious signals on the output of the AM transmitter. It'll just give it a better sound. It'll make it more stable and higher performance. And so you see, what we've done is we've taken a handful, just a tiny handful of parts, and we built something really cool with it. And this illustrates well why I don't sell PC boards. I think PC boards confine us, and breadboards rule. And this right here is one example of why breadboards rule.